Okay, so I will now go through the problem I shared last week. And my solution uses the brackets idea twice. So the first time, so of course, like you first notice that to find the coefficient of x to the power of 4, it is just all these combinations. And so x to the 5 is all of them multiplied together. X to the 4 will be, for example, this multiplied by this multiplied plus, this multiplied by this plus this multiplied. So the sum of all the possible ways to choose two of the brackets and multiply them together. And so we want to find them. Obviously, we don't want to do this by hand. So, well, we might notice that these are all symmetric. So, and also another thing we can notice is that the terms have a maximum power of 2. So the only terms that are there are r1 squared and all these squared. And you also get these where two terms are multiplied by together. So, and another thing I notice is that these are all symmetric. So if we find the number of r1 squared, then everything else will have the same coefficient. So let's try to find the coefficients of these two types of terms. So for r1 squared, it can only be achieved if you multiply this bracket by this bracket, or this bracket by this third bracket, or the second bracket by this third bracket. So these are the only ways you can get r1 squared. So same with everything else. So that's why the coefficient here is 3. And now you look at how many ways are there to get R1 and R2, which will be the same as the rest. Well, the coefficient will be same as the rest. So R1 and R2, you can achieve it. So here we got R2. Using bracket idea, you can think of this bracket multiplied by this bracket plus this bracket multiplied by this bracket. We have 2 already. Oops. Yeah, we have 2 already. And then we have this bracket multiplied by this bracket. Um, this so this bracket can multiply by this, and also don't forget that the second bracket can also multiply by the first bracket to get R2. So we have 3 for the second one, and for the third one with a 1, again it can multiply by the first bracket, can multiply by these two brackets. So again we have 3. These sum to 8, and we know that the coefficients of all the terms, like in the form of R1, R2, R2, R3, etc., have the coefficient of 8. Now that we know this, so all we need to do is find the value of this whole whole expression, and we can find that using Vieta. So this one, this one is just, well, this one is simply equal to the coefficient of, these are 6 terms, and they're equal to, I think if I remember correctly, it's this one. They're equal to -3 because we can do the Viettas of this one. Since these 6 roots are the roots of this p of x polynomial. So we can find this part pretty easily, but this part we can't directly find it using Viettas. So what we do is, well, then again, we use this, actually you showed in class about the 3 trinomial expansion. This one is like quadrinomial expansion or something. So again, you can use the bracket idea to find this, maybe. So yeah. So instead of ABCD, it should be R1, R2, R3, R4. But I wrote in ABCD because it's easier. So you wrote R1, R2, R3, R4 in this form. And you can find this, easily find the left part of this equation. That's -4. That's just this thing, negative a over b. Speaking of that, this should be 3, not negative 3, because it's... Wait, actually, it is negative 3. Never mind. So this side, we can easily find this, the left side of this equation. Now we just need to find the right. Well, we also know that this whole thing, again, we have 1, 2, 3, 4, 5, 6, we have 6 terms. So we know that this part is negative 3. See, and 2 times negative 3. Now we notice that we are left with this part. This part is exactly what we want to find, which is this part. So we can find the value, work out the value of this part, and it turns out to be 22. So we substitute 22 for this one, you get 66. And this part is 8 times negative 3. So this side is negative 24. And we add them together, and we get 42, which is the final solution.